This lesson is on section 6.6, special products of binomials. The two special circumstances I'm going to show you today are basically shortcuts. You don't necessarily have to do these shortcuts. You can still FOIL exactly the way we've been doing the entire chapter. So I'll kind of show you the shortcut, I'll remind you of foiling, and then I'll show you the second shortcut, and I'll remind you of foiling as well. So this shortcut, again, isn't necessary. You're not forced to have to use the shortcut. It's going to be extremely helpful towards the middle or the end of next chapter. So it is kind of, useful in that sense for you to pick up on the shortcut. But again, if you want to FOIL, because that's what you're more comfortable with, you can do that as well. Okay, so the first special circumstance is for perfect square trinomials. Perfect square trinomials are created when you have a binomial and that is being squared. So here I give you a bunch of colorful examples of what it looks like when you have a binomial and you are squaring it. So I'm going to show you the shortcut. Every single time that you do this, you are going to create a trinomial, a perfect square trinomial. Remember that a trinomial has 3 terms to it. So what you're going to do, for the first term, you take the first letter or number, variable, whatever it is, in the binomial, and you're going to square it. That is going to give you your first term. Then you're going to take the second one, and you are going to square that one. So 4 squared gives me 16. That's going to give you your third term. Now for the middle term, you are going to multiply these two together, which gives me 4x. X times 4 is 4x. And then you are going to multiply that by 2. It always gets multiplied by 2. Therefore, I have x squared plus 8x plus 16. And again, you can check your answer. If you didn't believe it, you could end up doing that and you could FOIL it out and you get the exact same answer. All right, so let's try it again. We're going to do it for every single one of these. All right, so I'm going to take my first term, which is y, and I'm going to square it. So it gives me y squared. Take my second term, which is 3 in the binomial, and I'm going to square that. 3 squared gives me 9, and that gives me my third term. To get the middle term, you are going to multiply the two together. Y times 3 is 3y, and then you are going to double that. When I double 3y, I get 6y. So my answer is y squared plus 6y plus 9. All right, our next one. I'm going to square the first term, which is a squared. The second term, now notice this one has a subtraction sign. It doesn't affect the third term because when I square -2, I'm going to get positive 4. So the negative sign does not affect the third term. It will, however, affect that middle term because when I multiply a times -2, that gives me -2a. And when I double -2a, I get -4a. So my answer is a squared minus 4a plus 4. Okay, next one. Again with the subtraction sign. I've got b. I'm going to square the first one, which is b squared. Square the second one. Again, when I square a negative number, it becomes positive. The third term is always going to be positive. That's one of the things that makes perfect square trinomials so magical. Next, I'm going to multiply b times -7. That gives me -7b. And then I'm going to double that, which gives me -14b. And that's my answer. All right, now I've got some ones with additional letters in there, but the rules are exactly the same. You're going to take your first term. In this case, it's 3x. So I have to square 3x. And when I do that, that gives me 9x squared. You have to square both the 3 and the x. For my third term, I'm going to take 2y. And I'm going to square that. That's going to give me positive 4y squared. Now for my middle term, I'm going to multiply 3x times 2y. That gives me 6xy. This needs to be multiplied by 2 or doubled, which will give me 12xy. All right, next one. I'm going to square the first term. That one's easy. 4 squared is 16. My third term, I have to take x squared, and I'm squaring it. So this requires you to remember the rules from the beginning of the chapter. When you square or you raise an exponent to an exponent, you multiply the exponent. So it'd be x to the 4th. That's positive x to the fourth. Now for my middle term, 4 times x squared is 4x squared. And then I need to multiply that by 2, which gives me 8x squared. Just the 4 got affected there, not the variable, because I was multiplying it by 2. All right. Take the first term, 5a. I want to take 5a and I want to square that. That gives me 25a squared. My second term is negative b squared. Once again, remember that negative sign does not really have an effect because it gets canceled out when it gets squared. For my middle term, I multiply 5a and negative b, which is going to give me negative 5ab. Then I need to multiply that by 2, which gives me negative 10ab. And this is my final answer. Now, if the shortcut, you're just not picking up the shortcut, go back to foiling. For example, x plus 4 squared. That's x plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is another 4x. And 4 times 4 is 16. The last thing you need to do is simplify and combine your like terms. And you will see you get the same answer. Now this example right here was the same exact as my first example right up in here. So it does not matter which way you want to go about doing it. The shortcut is really only going to really affect you in next chapter when you want to feel comfortable with these shortcuts a little bit more then. All right, so the second example, which we'll do foiling to remind you what it's like to foil. We have a negative sign in this one. 4c times 4c is 16c squared. 4c times negative 3d is negative 12d. Negative 3d times 4, oops, I forgot the c. 4cd. When I multiply the second round, I get negative 12cd again. And negative 3d times negative 3d is positive 9d squared. Again, I'm going to clean this up by combining my like terms. Negative 12 plus negative 12 is negative 24. Okay, on to our second example of a shortcut. This is called the difference of two squares. You're going to do this. This one actually is, I think this one's even a little bit easier, but you just have to pay close attention. When you have two sets of two binomials where one is subtraction, one is addition, everything else is the same. So it's exactly the same except for the signs. You're just going to square the first term and then square the second term, and it's always a subtraction sign in between. Hence the difference of two squares, different stands for subtraction. So let's do these examples down below. So as you can see, I have the exact same thing, x plus 6, x minus 6. Everything is the same, except one is plus, one is minus. So my shortcut here is I'm going to square the first term. My first term is x, so I'm going to square it. I'm going to square the second term, which is 6, which gives me 36. Slap a subtraction sign in between, and you're done. Let's take a look at the next one. The first term, x squared. So I want to square x squared. That gives me x to the fourth. The second term is 2y, and I'm going to square that. That gives me 4y squared. Again, it's always going to be a subtraction sign in between. The third one, my first term, 7 squared is 49. My second term is x, and when I square that, I get x squared, and again with the subtraction sign. All right, last example in this group, 3 times 3 is 9. Then I have 2y squared, and then I'm going to square that. That gives me 4y to the fourth. Again with the subtraction sign in between the two. Again, you can still FOIL if you'd like. So here's an example of the FOILing. X times x is x squared. X times negative 8 is minus 8. 8 plus x is 8x. 8 times negative 8 is negative 64. When you go to combine your like terms, the 8x's cancel out, and that gives me my answer. So again, just to show you that in reference to the shortcut we just went over, if you did notice that this was going to be the difference of two squares, square the first one, square the second one, and you put a negative sign in between. Notice, exact same answer. Last one, we'll do this where it has some extra letters and exponents and stuff. So again, with FOILing, p squared times p squared is p to the fourth. P squared times negative q is negative p squared times q. 8q times p squared is positive 8p squared times q. And 8q times negative 8q is negative 64q squared. Again, the middle terms cancel out. One is positive, one is negative of the same exact term. So they are alike. And then you have it right there. If, again, you wanted to use the shortcut, p squared and p squared gives me p to the fourth. 8q and negative 8q gives me negative 64q squared. The shortcut really does save you a lot of time on this. Again, it's just a matter of if it sticks for you. If it doesn't, go back to FOILing. But these are the only two shortcuts that there are, is a perfect square trinomial and a difference of two squares.